Okay, so hello everyone and welcome to Basic Calculus once again. So for this subject or for this topic, for this video, we are going to have a more focused nga discussion on calculus nga topic. Specifically, we will be discussing about derivatives. What I love about discussing this one is that I want to present kung di inaghalin ang istorya sa calculus. So, I am happy to discuss ang sininga story about calculus danay before kita mag-proceed with the discussion. So because I tried to research na sang sari-sari mga istorya about basic calculus and the origin of calculus. So I do hope wala na diri siya na akong gin-include sa presentation but I would like to present this para mas maintindihan man ninyo. So calculus comes from the Latin word man nga, calculus. So, it is a small stone for counting. So, basically, calculus is a branch of mathematics including some limits para sa na-studyhan na natin. And also, we have derivatives and we have integrals and infinite sum. So, for this nga term, we will be discussing about derivatives. And later on, we will have integral or its antiderivative. It is used in science, economics, and engineering. So it was built on algebra, geometry, and trigonometry with may ara siya duwa ka major nga branches. Sa nahamba ko na we have differential calculus and we have integral calculus. Okay, so if lantawan natin sa history, so ang the origin giniyang mahambal naton, it was in the earliest years that integral calculus was being used as an idea but was not yet formalized into a system. So ginagamit na nga daan ang idea balas ang integral calculus but we are not aware nga integral calculus na siya nga process. So calculating volumes and areas can be traced on the Egyptian Moscow nga papyrus. So if we are going to look at it, do ka advanced na naingadaan before sang mathematical nga advancement bala sa Egypt. So sa ila gid matrace back ang paggamit bala sang volume or pag-calculate sang volume pig sang areas. So because of kadamo sila mga ginpang obra nga mga structures at the same time ginagamit ni nila sa ilang mga writing sa papyrus. So, also sa ancient Greece, daw may mga damo nga mga advancement before. So we have Greek mathematicians. So if you could research, pwede gid you have Eudoxus. So he used the method of exhaustion as ang tawag. So it is precursor to limits nga ginagamit nato to calculate sang area kag volume. So that is Eudoxus. We also have Archimedes. So Archimedes naman niya, so gingamit niya o ginpadayon niya ang work ni Eudoxus. So it is an idea nga copy niya and then ginpadayon niya ang study. So ito similar naman sa integration nga topic. So nga ginagamit to calculate sang area. So in the time naman sang medieval na nga period, so in about 1000 AD, so may era kita mga Islamic na mathematician nga nag-made man sang advancement in mathematics. So they derived the formula for the sum of the fourth powers of arithmetic progressions. Later on, ang ini nga concept was used to perform integration. So kadamo man sa mga advancement nga natabo sa medieval nga history. So we also have some mga Persian mathematicians nga nag-discover some derivative of cubic nga polynomial. So sa modern history, if i-trace naton, we have Cavalieri. So I'm not um, very much familiar gid sa iyang storya gid balahaw but we have Bonaventure Cavalieri nga volumes ang iyang focus of study. Naghambal siya nga ang volumes kuno pwede naton ma-compute with the sum of the volumes of the cross-sectional section. So kung i-studyhan nimo or i-solve nimo ang gagmay-gagmay nga cross-sectional section of a specific nga object, so makuha nimo ang volume niya. So, however, Cavalieri's work was not well respected. So his infinitesimal quantities were not accepted sa una-una niya nga pag-present. So, we have a lot of mga mathematician nga wala nag-agree sa iya nga concept. But later on, syempre may ara sang nagamit man sang same nga concept with what Cavalieri presented. So we have mga taho ang kilala in the field of calculus. We have John Wallace, we have Isaac Barrow, and James Gregory. So I will not be presenting this nga dapat nakasulat-sulat yun because this is just a history. So kabay pa nga pabatian ta lang kag kabay pa nga we could do research man about history of calculus. So later on gingamit nila ang concept ni Cavalieri para mag ah, perform sa isa ka work about sa fundamental theorem of calculus na gin-publish nila in the year 1675. So ang pinagid ka dako nga name in the field of calculus would be Sir Isaac Newton. So, Sir Isaac Newton, he was credited sa many of the beginnings of calculus. So, he introduced, syempre, what will be discussed in the next few weeks. So, he ginintroduce niya ang product rule, chain rule, higher nga mga derivatives to solve sa mga physics nga problem. So, he replaced the calculus of infinitesimals with geometric nga mga representations. So he used calculus to explain many physics nga mga problems in his book. So ang book ni Isaac Newton was entitled as Principia Mathematica. So, however, he had developed many of other calculus explanations that he did not formally publish. So, another name very well known in the field of calculus would be Leibniz. So, we have Gottfried Wilhelm von Leibniz. So he is a German mathematician nga ang iyang work could be somewhat similar sa ginhimo ni Newton. So Leibniz spent time to determine the appropriate nga symbol nga kinahanglan naton gamiton and paid more attention to formality. So his work leads to formulas for product and chain rule paris man sang ginobra ni Newton. So rules for derivatives and integrals paris ang work ni Newton. So because of the similarities ng work ni Newton kag ni Leibniz. So, there was much more controversy kung sino gid or sa diin nga country naghalin or kung kay sino nga mathematician i-credit ang ang calculus since both sa ila work at the same time. So, Newton derived his result first. So, take note lang, si Newton ang una gid nga nakakuha sang results but ang una nga nag-publish sang book about sa calculus is Leibniz. So, Newton, syempre kay una siya nakaobra sang result, he claimed nga gin-copy ni Leibniz or ginkawat ni Leibniz ang iya nga ideas. So, hambal niya, Leibniz kuno stole the ideas from the unpublished notes kuno ni Newton sa naging sulat sa mga royal societies. So this divided sa amo na nga time sa mga English speaking math kag continental math for many years. So syempre there have been faction na dayon between sa duha ka uh, supporter. So supporter ni Leibniz at supporter ni Newton. So today, so it is known that Newton began his work with derivatives and Leibniz began with integrals. So both arrive at the same conclusion. So later on, ma-discover na naton as we go on with the subject kung ano ang relationship with the derivative and integral. So si Leibniz nag-start siya sa integral, si Newton nag-start siya sa derivative, but they arrive with the same result. So the name of the study nga gingamit ni nga ginhatag ni Leibniz, gitawag na siya ni Newton nga the science of fluxions or changes. Changing this is referred to the engineering discussions, that is fluxions is changes in electric fields. So we have science of fluxions or science of changes. Since then, there have been many contributions to build upon Newton and Leibniz. So calculus was put on a more rigorous nga footing by mathematicians such as we have mga kilalang mathematicians which developed some more advanced nga study on calculus. We have Cauchy, we have Riemann, and we have mga iban pa nga mga mathematicians. So calculus has also been generalized for the Euclidean kag complex nga space. So it should not be deal good nga dalom about sa sinang part because that will be discussed more on your college days ng mga subjects. So, what is important here is that you have the idea kung kay sino nag-originate ang calculus. So, we have Newton and we have Leibniz. So, let's proceed sa una natin nga topic about calculus which is about derivatives. So derivatives is all about slope. So kung lang tawag natin, ang mugid niyang focus of the study of derivatives. So if we go back sa discussion ng slope, we will know ng slope is your rise over run. So that is your change. So may change ka sa imong y and then change sa imong x. So di ba ang formula for slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So that is for the slope. So we can find an average slope between 2 points. So syempre, kabalo na kita sina. So we have the rise over run. Kaya na-discuss na natin sa precalculus. So let's proceed. How about how do we find the slope at a point where there is nothing to measure? So for example, at a point lang, so wala kadua ka point nga pwede i-consider. So that could be impossible nga ma-solve kita kay makaproduce kita sang um, indeterminate nga value because syempre kung ara ka sa point that will be 0 all over 0 na so that is an indeterminate nga value. So the best way to do that is so but with derivatives nga topic or sa derivatives nga way of solving so we use a small nga difference. So pwedeng i-zoom in mo gid ang graph. So ma-zoom in kay kung ma-zoom in hasta nga approximately zero ang imong values but still you have the value nga though lapit-lapit na sila sa zero but you have so for example you have duwa ka point so approximately zero na ni sila isa na ni sila ka point so diri sila halin sa gamay nga point but if i-zoom in mo sila mo ning ila itsura so you still have your change in y and you still have your change in x. So mo lang man ang concept of your derivative. So now let us try to understand what is derivative. So find the derivative of function y is equal to function of x. We use the slope formula. So simply lang change in y over change in x man Japon or delta y over delta x. So kung mukha mo nga value delta y over delta x, that will be your derivative na dayon. So that is slope sang graph. So, and from the diagram, we see that x changes from, so there is a graph, we have ang imong x, halin siya sa imong x hasta sa x plus delta x. So, ang ari nga point, we have x and y, or x kag function of x. So, ang aton naman nga value, dari we have ang x natin nga value is x plus delta x. Ang aton y nga value is function of x plus delta x. So, or pwede man nga y plus delta y. So, that's it para sa sina nga points. So, pwede nga if we are going to solve, we are going to use ang sinila nga slope formula. But we still have the 4 step na formula pwede gamiton para mas maintindihan. So that is what we refer to as our delta method. So first, una sa delta method is in the given equation, replace x by x plus delta x and y with y plus delta y. And then we are going to simplify. Next, find the delta y by subtracting the given equation from the equation obtained in step 1. So then simplify. Divide both sides of the equation obtained in the step 2 by delta x and then simplify again. Find the limit as delta x approaches 0. So take note that we introduced the concept of limit sa previous nga discussion because we are going to use that topic sa sini nga discussion. So, medyo hindi pa klaro kung paano himuon ang delta method, but what's best to present sa sini nga method by having an example about sa sini nga discussion. So we have example, we have y is equal to x squared. So for this step 1 we have, so ang tanan ko nga y i-replace na sila by y plus delta y. Ang tanan nga x butangan mo x plus delta x. So next, kung nabutang mo na, then you have to substitute or you have to manipulate na sa iyong mga mathematical equation. So, expand na natin, we have x squared plus 2x delta x plus delta x squared. Then, after sina, so pwede na, na-expand na natin, subtract natin ang original equation. Y is equal to x squared. So, makansel na ni ang y, mabiling di sa aton nga left side will be delta y. Makansel man ang x squared, mabiling sa aton right side will be 2x plus delta x squared. Then, after sina, we know nga hamba kagina makakuha mo ang derivative if we have delta y over delta x. So, divide sila natin by delta x para makuha ang derivative. So, we have delta y over delta x. Divide natin. So, nag-divide kita sa left side, so we need to divide on the right side man. So, we have 2x delta x plus delta x squared ang bilog na quantity all over delta x. So, next, we have nasa sini nga value, pwede tayo makancel ang delta x sa right side of the equation. We have delta x, ang mabiling 2x na lang. Then delta x delta x squared over delta x, ang mabiling delta x na lang. So, then, ang imong himon then is to find the limit as your delta x approaches 0. So, ang matabo lang man, substitutean mo ang imong delta x with 0. So, substitute 0 sa delta x, so this will be 2x plus 0. So, aton delta x, so, pag delta y over delta x, we could be, pwede natin siya i-rewrite. We could rewrite it sa form na dy over dx. So, delta y over delta x or dy dx is equal to 2x. So, mo lang man na ang aton nga pwede himuon. So actually we have apat lang gid ka steps na pwede himuon, but gin-elaborate ko lang dali sa aton nga solution para mas klaro. Another example, so same man siya po nga process, we have y is equal to 4x squared plus 15. So ang pwede natin himuon is to substitute y with y plus delta y and x with x plus delta x squared plus 15. So, nag-substitute lang kita dari and then we use mathematical operation. Expand natin. So, x squared plus 2x delta x plus delta x squared plus 15. So, after subtract natin ang original equation, y for x squared plus 15. So, ang mabilin, makancel ang y, makancel ang 4x squared, makancel ang 15. Mabilin dito sa left side will be delta y. Mabilin sa right side will be 8x delta x plus 4 delta x squared. Then, divide kita by delta x on both sides of the equation. So, we have delta y over delta x will be equal to sini nga equation 8x delta x plus delta x squared. So, all over delta x. Then, pwede na natin i-simplify, divide natin ang delta x, mabiling 8x plus delta x. And then we perform sa limits, substitute kita 0 sa aton nga delta x because our delta x should approach sa 0 nga value. So we have, ang mabilin, substitutean natin 0 ang delta x, mabilin is 8x. So, gamiton na dahil natin nga symbol is dy over dx. So that's it para sa delta method in solving sang differential or derivative sang equation. So,